The blower door test, a critical element in any home energy audit, will determine the air tightness of the home and locate the sites of air leakage. After closing all the windows and doors, Larry installs a giant calibrated fan, creating a pressure difference between the inside and outside. This will force air through any holes or penetrations in the house, which can then be measured.
So we're depressurizing the house to 50 pascals. Pascals is just a unit of measure for pressure. So we're depressurizing the house with a 50 pascal difference between inside and outside. Inside being 0, outside being 50. So when we go around taking measurements, a bedroom, for example, when I measure the pressure in the bedroom, should be reading 0, meaning there's no infiltration from the outside. The higher that number above 0 is to 50 indicates airflow, unwanted airflow from outside or the attic to that room. So we're going to go take measurements. So this flue is sealing fairly well, and you know, at best we could put a chimney pillow in. I don't know that I'd spend much more money on trying to work on this chimney when it's not so bad. We're going to check all the windows in each room of the house to see how leaky they may be. They're older windows. They do have storms on the outside, which does help reduce air infiltration. This window appears to be very tight. I'm not getting a lot of airflow through the tracks, which is a normal spot where air will flow through a window. So even the fact that this is an old window, it's still sealed very well, and you know, is not necessarily a reason to replace the window based on air infiltration. You do have single pane glass, so there is conductive heat loss through the glass, whereas the glass on this door is double paned, so it's going to have more of a thermal resistance to cold air or warm air, and has better thermal properties. Okay, so now I'm going to test while the blower door is running with my manometer to see if there's any unwanted airflow in this bathroom here. Now again, we should be getting a reading of 0 pascals if there isn't a lot of airflow from the outside to the inside. Any number over 0 means there's some kind of air infiltration going on. I'm going to stick my probe underneath the door, shut the door, and we're getting a reading 4.5, 4.5, and I could actually feel a breeze coming from underneath the door jamb here, the door threshold. So there's something going on here. So we're going to go inside this bathroom to see if there's an obvious culprit. Initially, there wasn't an obvious reason for airflow. When I got down to the floor to feel around the baseboard, I can feel cold air rushing in from underneath the baseboard molding. So there's probably some kind of ceiling penetration in the basement that's allowing air to get up into the floors and into the bathroom here. Okay, so we're going to check our exterior doors to see if there's any air leakage. And because the blower door is running, it's pulling air out of the house, which is going to pull air in wherever there's air infiltration. And if we go down to the bottom of the door here, we feel a pretty big rush of air. And as you can see, there's a clear gap to the outside. So this is a weakness in the thermal boundary here, and something that should get fixed. We will pop in here real quick to see if there's any obvious holes that could be patched up. So there's a couple of obvious spots here. And if we put our hand here, there's a big rush of air. See how it's being sucked into the wall cavity? That's because there's communication with the garage and the rest of the house. That's bad for 2 reasons. 1, unconditioned space gets very cold in the wintertime, so you're going to have warm air from the house finding its way into the garage, heat loss. And 2, if a car's running in here and there's carbon monoxide in the garage, it could potentially be pulled into the house. So that's another health and safety issue that we want to be aware of.
With the blower door fan still pulling air out of the house, Larry tests the basement.
It's not a bad number. While the basement's not a conditioned space, we don't want to see a lot of air infiltration in a basement. So you want to seal all the holes and penetrations in the basement that allow air from the outside to come in.
Now he looks for the source of those air leaks.
We have air flow coming from the foundation. So these cracks in the foundation here, we could feel a nice amount of airflow. This is the rim joist here, this band of wood that sits on the foundation wall. You have right angles when they construct the house, and those are generally poorly sealed. So one of the more common measures to seal your basement is to insulate that rim joist all the way around the perimeter, and that'll generally be done when it's accessible with a 2-part foam that they'll just spray there and seal it up nice and tight. Okay, so we've got 3 prime areas of airflow from the basement going up to the rest of the house. First, we have a crawl space here, and I could feel air rushing at me from the crawl space. We have a pipe here. In all likelihood, this is going all the way up through the house into the attic. So not only will we have a hole in the basement floor, we have a hole in the attic floor, and that's a chimney. And that's bringing air up through the house. It's going to take your warm, heated air with it. And then we have a penetration in the ceiling where the ductwork is. It's not sealed, so you have an opening in the floor. And these are all spots that we're going to want to do something about. Sealing that up with foam so air can't get up, and sealing the penetrations with the pipes, sealing that up with some foam so air can't get in there. And then closing off the ventilation in the crawl space.
And upstairs in the master bedroom, there's yet another problem with air leakage.
Because their central air conditioning is not doing a good enough job cooling the upstairs, which is a common problem, they put in a window unit into their windows. But as a result, basically this window's wide open, and air's rushing in right now because of the blower door pulling it in. So this is like keeping a window open in their house, which is a big energy waste, and it's also going to affect their comfort. It's going to make them have to run this window unit a lot longer. We finished with our visual inspection and running our diagnostic tests on the house. We're going to take the data that we collected, bring it back to the office, put it in our computer model, see if we can get estimates of how much energy we'll be able to save by implementing weatherization improvements.
The modeling program calculated that the homeowner would need to spend approximately $1,000 to fix the air infiltration problems. She would save $152 a year on energy bills, so payback would take about 6 years. Adding insulation to the exterior walls would cost about $4,800. The energy savings would be $692 per year, so payback would take approximately 7 years.